Alright, ladies and gentlemen, these are some video notes here on 6-2 notes on ratios and side lengths of a right triangle here. I'm going to try to walk you through it using the notes via the PDF there. Unfortunately, I left my smartboard notes at school, and hopefully we'll be able to redo a newer video that looks a little bit nicer and prettier than this one. But at least this will get us going here. You do now take out your writing utensil and your calculator. Objective, you'll be able to find a missing angle in a triangle when given two side lengths. Alright, we're also going to find the ratios and the side length of a triangle here. These are the notes that we seen on Friday before we left. There are 3 buttons on your graphing calculator that we're going to go over today. Here's your little graphing calculator. It's located right here, sine, cosine, and tangent. These 3 buttons will be used often in our upcoming classes. So, first thing we need to do is we have to get comfortable with the buttons on the calculator. And what we need to do is we have to clear the RAM. So to do that, we need to hit the on button, then the second button, then the plus sign, 712. And then enter. That will clear the RAM for us. Next, I need to hit the mode button on our calculator, which is just to the right of the second button. And make sure your calculator is in degrees. So going from radians to degrees. The reason why we're going to be doing this is just so we make sure we get all the correct answers here, make sure all the side lengths are correct. So let's discuss the trig ratios. Let's try this. There we go. These are the ratios of side lengths of 2 sides of a triangle. Sine works with 2 sides. Cosine works with a different 2 sides, and tangent of x works with 2 different other sides. They do overlap each other. And you see a little bit more as we progress here. Now, everything starts with a reference angle in a triangle. That is the point where we refer to as the starting point. So this is the reference angle here, 64 degrees. So that's our starting point, like where we're starting the race, where we're starting from the problem. We need to know what the reference angle is so we know where to begin. Here's some of the basics. The trig function, it's either sine of x, cosine of x, or tangent of x, or the inverse operations, which we're going to discuss too. Also there to find angles. Parentheses, our reference angle goes inside the parentheses, and it's equal to the ratio of the sides, or a decimal. When you hit in the calculator, a decimal comes out. Then I had you guys write this down for yourself. This is SOHCAHTOA. It's just SOHCAHTOA is an acronym to help you memorize these formulas here, where sine of x equals opposite divided by hypotenuse, cosine of x is adjacent over hypotenuse, and tangent of x is opposite over adjacent. They're going to be using that quite a bit, so it'd be a good idea to remember those. Alright. So let's practice a few together with just some decimals. So sine of 45. What we got to do with the on the button on the calculator, we type in the SIN button, or the sine button. 45 degrees, we type that in, close parentheses, enter, and we get 0.707. So 0.707. Can I write on this? I cannot. So 0.707 for this one right here. Then we type in cosine of 23. And cosine of 23, we're going to get 0.9205. Tangent of 16. So we type in tangent, or TAN, 16, close parentheses, and we get 0.2867 dot dot dot. You can try a couple on your own. Give you a quick second, then I'll just go through them right now. Sine of 75, get you 0.965. Cosine of 13, get you 0.9743. And tangent of 56, that gets you 1.482. Dot, dot, dot. So that's just practicing typing it into the calculator. Now let's apply this to some ratio stuff. So now, find the values of each trigonomic ratio. Zoom in. We could see cosine of z. Cosine is the trig function. Z refers to the angle that we're starting from. So we're starting from the z angle, from right here. This is our reference angle where my mouse is. So we have cosine. So cosine involves adjacent and hypotenuse. So adjacent is right here, 9, and the hypotenuse, which is across from the 90-degree angle, is 41. So cosine of z, that'd be cosine, would be 9 over 41. So 9 over 41. The answer for number 1 would be D. Let's try number 2. We got sine of z. Well, z is our reference angle. That means starting right here. Our opposite, labeled O, OPP, is 32. Our adjacent is 24. And our hypotenuse is 40. And we're looking for sine. So sine is opposite divided by hypotenuse. That would be 32 over 40. Now 32 over 40, you can see in our multiple choice, it's not there. Well, what we have to do, we have to simplify that fraction, make it smaller numbers. So what we do on our calculator, we type in 32 divided by 40. Then you can hit this combination of buttons called Math 1 Enter. What Math 1 Enter does, that combination of buttons, it simplifies the fraction. So 32 divided by 40, Math 1 Enter, it's going to simplify down to 4/5. That's how we get D. Let's try number 3 here. So you have sine of x. X is right here. Sine is opposite over hypotenuse. So it would be 15 over 25. 15 over 25, when we hit Math 1 Enter, that's going to simplify down to 3/5. So 3 is C, 3/5. Which is located right there, 3/5. Let's try number 4. Number 4 is cosine of A. So my reference angle is right here, A. Cosine is adjacent over hypotenuse. So 21 over 29. So 21 over 29. Now my answer would be B. Here's another one. Find the value of each trig ratio. So we have tangent of C. Well, C is my reference angle, so that means I'm starting right here in this angle. Tangent is opposite over adjacent, so my opposite is 24, and my adjacent is 32. So this is 24 over 32. I don't have that in my multiple choice. That means I got to simplify it down. 24 over 32. Well, 8 goes into 24 and 32. So that would be 3/4. So my answer would be 3/4 B. Now we're going to solve for missing side length. That's coming up next. We're going to still be using SOHCAHTOA. Up some notes again. Here we go. So we got 3 more examples to go. This is how you find side lengths. So our goal is to solve for x right here, to find this length from top to bottom. To do this, we're going to use our trig function sine of x. Our reference angle here is 15. X is our opposite. 20 is our hypotenuse because it's the furthest away from the 90-degree angle. So we're going to do sine of 15 is equal to x divided by 20. So now, what we got to do, we got to do 20. Because 20 is on the bottom, so you multiply by 20 to both sides. So it's going to be 20 times sine of 15. And now get us the value of x. So 20 times sine of 15. We put that in the calculator. 20 times sine of 15. we're going to get 5.17. So the height right here is 5.17. Let's try another one. Let's try it with cosine. So cosine is adjacent over hypotenuse. So adjacent over hypotenuse. This is, of course, by the reference angle of 15. So x is in the adjacent spot. 20 is in the hypotenuse spot. So it's x over 20. You multiply by 20 to both sides. So we got 20 times cosine of 15 degrees. And now find us this x length. So 20 times cosine of 15. That will get us 19.3185 ... So 19.31 rounded. All right, let's try one with tangent. So tangent of x is opposite over adjacent. So you have 15 degrees as your reference angle again. Your opposite is x. Your adjacent is 20. So it'll be x over 20, so x on top, 20 on bottom. We gotta multiply by 20 to both sides, so it's gonna be 20 times tangent of 15. So 20 times tangent of 15 is gonna get us 5.3589. So 5.35 or 5.36, those are all good, acceptable answers. And then we move on to angles, which is in our lesson. All right, if you have any questions, feel free to send me an email. I'll be happy to help you out. And of course, good luck. See you in class.